Quadratic models using vertex form. Our learning goal today is to use vertex form to represent equations in the shape of parabolas. Please ensure you have the lesson printouts so you can follow along with this video. If we are given information that approximates a parabola, all that is necessary to create an equation in vertex form is information about the vertex and one additional point to solve for the a value. Recall, the h value represents the axis of symmetry, and it is the x value of the vertex. The k value represents the y value of the vertex. So if we have the vertex, we already know the h value and the k value. We will now go through several examples of how we can use this information to solve for the equation of a quadratic given the vertex and one point. Example 1. The Best Bread Bakery wants to determine its daily profit from bread sales. This graph shows the data gathered by the company. Examining the data, we're clearly given the vertex at 1.75, 400. So we're given the h value and the k value. So let's fill in our skeleton of the vertex form. So we know the h, so let's fill that in. We know our k is 400. We're missing our a still, so we just need to find a now. Examining the parabola again, we're very clearly given one of the points here, 0.75, 300. So we know an x and y value that exists on this parabola. So we can fill in those data and solve for a. Let's go ahead and do that. So we know y is equal to 300 when x is equal to 0.75. So now we can solve for a. To do that, we're going to simplify this bracket here first. 0.75 minus 1.75 is going to be negative 1. We still have to do the exponents. I'll do that right after this. So you have a times negative 1 squared plus 400. And following Bedmus, we do brackets first. That's why we did brackets up here. Now we're going to do the exponent. 1 squared is just 1. So a times 1 is plus 400 is equal to 300. Now we just need to solve for what a is. So we're going to move the 400 to the other side. So 300 minus 400 is equal to a. And 1 times a is just a. And so we can conclude that a is going to be equal to 300 minus 400, which is 100. Therefore, we can conclude our total equation. So now we know what a is. Our total equation is going to be y is equal to negative 100 bracket x minus 1.75 close bracket squared plus 400. And this would be our final answer here. So let's recap our steps. The first thing we did was find the vertex and we plugged it into the skeleton equation. So we found the vertex and we plugged in h and k into our skeleton equation. Number 2, we found a good point on our graph. So we did that over here. And plug in for x and y. In step 3, we just solved for A. So step 3 begins right over here. And finally, step 4, state the equation. As we know, with word problems, it's very useful to draw diagrams to represent the situation. This helps us identify key points, and with quadratics, it helps us align our axes to help us answer questions in a simple way. So let's try example 2 and do just that. A child kicks a soccer ball so that it barely clears a 4-meter fence. The soccer ball lands 6 meters from the fence. Determine the equation in vertex form of a quadratic relation that models the path of the ball. So let's draw our little diagram. Here we have our child, and he's kicking the soccer ball, and we know it forms a parabolic arch, and it lands on the other side. Okay, we know it clears a fence that's barely, or that is 4 meters tall, and we know that it lands 6 meters away from the fence. So if we centered our Cartesian plane right on this spot here, the fence would be on the y-axis. And for it to clear just barely over 4 meters, we can assume that, and if we center this at 0, and this is our y-axis, this is going to be 0, 4 for our vertex. And since it lands 6 meters away, this distance here is going to be 6, 0, where 0 is the ground and 6 is that 6 meters away. So now we have our good points, and we have our h and k value, our vertex. So let's fill in what we know. So we have our vertex of 0, 4, and that's our h, and that's our k. And now we can start filling in our skeleton equation. Y is equal to a bracket x minus h squared plus k, and we know h is 0, so we don't even have to include it here, so we're just going to skip that. And we know k is 4. We don't know what a is, but we do have a good point, and that's this when it lands on the ground. The x value is going to be 6. Our y value is going to be 0. Okay, before we go anywhere, let's use some bed math. We've got to do exponents, so we're going to clear up this 6x squared here, which is going to be 36. So a times 36 plus 4 is equal to 0. We're going to move the 4 over to the other side, so it becomes negative 4 is equal to a times 36. Now we want to get a by itself, so we're going to divide both sides by 36. And let's bring that up here. When this reduces, negative 4 divided by 36 is going to be equal to negative 1 over 9. And that will be our a value, because these are going to cancel here. And now we can write our equation. Y is equal to negative 1 over 9 bracket x, because h is 0, we don't have to include it, squared plus k, which is 4. And this is an equation that models the soccer ball. Example 3. A suspension bridge spans a distance of 1,012 meters. Large cables are attached to the tops of the towers, 45 meters above the road. The road is suspended from large cables by many smaller vertical cables. The smallest vertical cables measure about 1.5 meters. Use this information to determine a quadratic model for the large cables. So if you guys don't know, this is what a suspension bridge looks like, and you can see that these large cables here model a parabola. And so we want to figure out what that parabola is. What is that equation? And so we're going to use a very similar idea from the previous example to help us solve this example here. So let's start off by drawing a model of that parabola over here. So we have some information. Okay, we'll draw a model of this bridge here. And so we know, it says here that the whole bridge spans 1,012 meters. And we know the towers are 45 meters above the road. Okay, so we know the Y values above the road are 45 meters. Okay, so we know these are the Y values. What we can do is, like last time, if we center our Cartesian plane right on the center of this, that would mean if we're going to center that, the total distance from here to here we know has to be, so this is our 0 line, this has to be 112 meters. We can divide it up on each side of the number line. So if we divide it in 2, this would be negative 506 for our x value, and this would be positive 506 for our other value. If we add the total distance between negative 506 and 506 is 1,012. So we're just centering the bridge right on our y-axis there. Okay, and one other piece of information, we know this will be the x value of the vertex here. We know the vertex is going to be here is 0, and our y value, it says here, is 1.5 meters. So the shortest cables holding it up right in the center are going to be 1.5 meters. So this is going to be 1.5 meters tall. So we can therefore conclude our vertex is 0 and 1.5. So now we have all our information to write out the equation for these big cables. And so let's go ahead and do that. We know our vertex from this is going to be 0, 1.5. Okay, so that's the height of the small cables holding it up. And we want to find the equation of these big cables, the red one here. And so we know our vertex. We can start filling in our vertex form. A bracket x minus h squared plus k. So we know that this is 0 for h. And this is 1.5. We know x minus 0 is just x squared. Plus 1.5. We have our a, we have our y. And so we just have to plug in one of these values here. We know one of the values is going to be, our x is 506 and our y is going to be 45 meters tall. So we know at y is equal to 45, x is equal to 506. Okay. So now we just have to solve for what a is. So we're going to move the 1.5 to the other side. So we have 45 minus 1.5 is equal to a bracket 506 squared. And 506 squared, that's going to be, if we plug that into a calculator, we're going to get 256,036. And 45 minus 1.5, that's 43.5. Now to solve for a, we just divide both sides by this number here, 256,036, 256,036. These ones are going to cancel here. So now we have our a value. So now that we have our a value, we can just plug everything into our final equation here. So you know y is equal to a, which is 43.5 over 256,036, and you can simplify that and get a decimal if you like. And then we have our x minus h, but since h is 0, we don't have to include it, so we can say x squared, and our k, which is 1.5. So there is our final equation that represents this cable right over here. And some key notes, we center it on the y-axis there, and we split up the total distance that it spans on either side. So we divide it by 2, we make 1/2 negative, 1/2 positive, and that's how we go ahead and do that. So hopefully that was clear. And if you have any questions, you could always ask me about this particular question. Okay, so this is our last example here, and it's very similar to the revenue product value that we've done before, those types of questions, except we know the maximum profit and the amount that we're going to be selling our product at. So we're going to use that information and solve for our equation. Example 4. The owner of a small clothing company wants to create a mathematical model for the company's daily profit, P, in dollars, based on the selling price, D, of dresses made. The owner has noticed that the maximum daily profit the company has made is $1,200. This occurred when the dresses were sold for $65 each. The owner also noticed that the selling dresses for $50 resulted in a profit of $900. Using a quadratic relation to model this problem, create an equation for the company's daily profit. So we do know the maximum here that we will make. It says here, the maximum daily profit the company has made is $1,200. This occurs when the dresses were sold for $65 each. So before we go any farther, let me just show you what the equation would look like. We're setting it up in Vertex form. So P is our profit. It's going to be equal to A times the value of our dress, where H will be the price that we want to sell our dress at to get our maximum, plus our K value, which is going to be our maximum profit that we're going to make. Okay, so this is going to be where we put the dress price. This is where we're going to put the profits. H is going to be to get our maximum, this is going to be our H value, the dress price at max, and this is going to be the max profit here. Okay, so it sets up pretty much the same as we've always been doing. Okay, so we know D is equal to our dress price, and we know our maximum occurs when our dress price is at $65. So our H is equal to dress price is $65. Our K is our profits at maximum. So K at our profit, maximum profit is going to be $1,200. So we know our H, we know our K, and we know everything else, what everything represents here. So let's put it all together. So we have P is equal to A bracket D minus 65, the maximum, the dress price that'll get us our maximum, squared plus the maximum revenue, which is going to be $1,200. Okay, so we want to find the full equation, so we just need to figure out what A is. And to do that, we just need one good point, and we do have one here, 50 and 900. Okay, so we know the profit is equal to 900 when D is equal to 50. So we're going to plug that value into this equation here. So 900 is going to be equal to A bracket is going to be 50 minus 65 squared plus 1200. And now we just go ahead and solve for A. So we'll finish off with this bracket here. So 50 minus 65, that's negative 15 squared. There's an A. We have 1200 is equal to 900. We can square this. Negative 15 is going to be equal to negative 225. Oh, sorry, positive 225 plus 1200 times A is equal to 900. So you're going to get something that looks like this. So now we want to move the 1200 over to the other side. Let's go ahead and do that. 900 minus 1200 is equal to A times 225. And so let's clean this up. 900 minus 1200, that's negative 300 is equal to A times 225. We're going to divide both sides by 225 to get what A is. These are going to cancel, and we could reduce this, nicely to negative 4 over 3. And so that's going to be equal to our A. So now that we know our A, we can put it all together and get our equation. And if you're having any difficulties reducing this value here, you could always just turn it to a decimal and it'll also be correct. But if you reduce it, you should get negative 4 over 3 in this case. So let's put it all together and get our final equation. So our profit is equal to negative 4 over 3 bracket D minus 65 squared plus our K value, which is 1200. And so this is our equation that represents the scenario in vertex form. And just one tip, if you're having difficulty reducing that, and if you just want to be safe to make sure you don't make mistakes, you could just turn that into a decimal, and that is going to be equal to, if you divide negative 300 by 225 is equal to negative 1.33. So A is equal to negative 1.33. So you could convert it to a decimal and state the A value as a decimal. And so I'll write that down here for you as a complete equation, 1.33 times D minus 65 squared plus 1200. Okay, so either of these are correct. And if you wrote these on a test, you get either of them full marks for that, okay? So your homework is going to be based upon this stuff. Not too difficult, not too different from what we've been doing, and pretty straightforward, I think. So try it out, and if you have any questions, please ask me.